Hello and welcome to Research Matters podcast. On this episode of the Joy of Science series, I have with me Professor P.K. Joshi from Jawaharlal Nehru University, Delhi. Professor P.K. Joshi's research focuses on environmental studies, including landscape characterization and climate change. In the past, he has characterized the biodiversity of plants in Ladakh and has also studied the human population density in Beijing. Many of his studies use geospatial analysis and modeling of the land and deciphers how the land used and the vegetation found in a region using remote sensing data. With the looming climate crisis, such studies help us understand the effects of global heating on different regions of the country. Today, I am talking to him to find out what it would be like to work in the realm of geospatial analysis and the joy of doing this science. Professor, thank you so much for joining us and welcome to this episode of Joy of Science.
Well, thank you. It's my pleasure.
So, one of your research areas are advanced geospatial analysis and modeling. When you started your career, was this what you were going to start off with, and what was your motivation behind it?
Well, when I was doing my master's in environmental sciences, I thought of going for higher research. And at that time probably I was not knowing about the tools and techniques which are available. But my objective was very clear that I wish to do something related to immediate human environment.
Okay.
So I got, during my studies, I got attracted towards the science of remote sensing and GIS. And fortunately, I got an opportunity to get connected with Indian Institute of Remote Sensing as a IGBP fellow. Wherein, I learned the technology, I learned the science, and I learned the applications of this. That was the beginning of the research journey while using remote sensing, GIS as fundamental tools for most of the research which I do as on data as well.
Right. And I'm sure that since, as with any other technology, it's advancing since you learned it.
Yeah.
And it's getting more and more complicated, more and more technical. So,
certainly.
So did you have to learn anything? Do you still learn anything on the job?
Yeah, in fact, the way you look at data, the way you process it, the technology is changing.
Right.
The algorithms are changing. And it being more of a multidisciplinary and interdisciplinary in nature, you need to know the other domains as well. Because every now and then people are looking at how different algorithms, theories could be applied to such type of data set. So you need to keep your eyes open, keep reading a newer text, and even interacting with the new generation.
Yes, of course.
And specifically students, because they come with newer ideas, they come with a altogether different way of thinking. So I am very happy and fortunate that I am in a university setup. I interact with students not only in classroom but also in my laboratory. So that keeps me updating about newer things which are happening.
Could you please help us understand exactly what this field of science entails? And what is the data that you spoke about that you deal with?
Well, primarily we use the photographs, we call them imageries, which are captured by satellites which are moving around the Earth. These are called as remote sensing satellites.
Right.
These provide you pictures in different scales, different spatial resolutions. I primarily work on terrestrial ecosystems.
Okay.
It is forest, agriculture or human settlement.
Right.
So my most of the usage of data is to look into the changes which have taken place over the time.
So just to understand this a bit more, when we use Google Earth, right? So we see a landscape, we see the terrestrial ecosystem as you speak of. So what you do is that you see different snapshots at different periods of time and compare them?
Yes,
Okay.
certainly.
Okay.
What you see in Google Earth, that is, collage of data sets which are collected at different time periods, different resolutions for a common person.
Okay.
So that a common man, right from a school-going kid to somebody who looks into strategies, can take help from Google Earth. My research is primarily looking at satellite data, which is not as true as what you see on Google Earth, but it is more of a false color.
Okay.
And then some of the bands in which data is hidden. So using some of the techniques, I try to extract that information from the data set. The beauty of the science is you are always able to see the past and something which is almost real time.
Got it.
And detecting the changes which have taken place over the period and time That is something very interesting, and looking at the causal factors for such type of changes.
What are some of the insights we can get from remote sensing data, and how does it help us understand the world we live in?
Well, to me, it is a spatial data, and spatial is a spatial in the sense you get to see many of the things which otherwise you are not able to visualize. You get a snapshot, a synoptic view of the Earth surface or the area which you are interested in. So, looking at spatial relationships, what is next to what and why, how these two objects are interacting with each other.
Right, and how one may affect the other.
Yeah, certainly.
Okay.
So, and then, this is a spatial scale. Then you have a temporal scale on this because you are able to see past as well. So, looking at how over the time and over the space, things are interacting with each other. And human being plays a very crucial role in that because most of the landscape as on date, those are dominated by human beings.
Yes.
Even if you minus human beings from these landscapes, there are natural landscapes wherein wilderness, plants are there, trees are there, animals are moving around, even over the no man's land, which are covered with glaciers, snow and all. So you want to see how spatially things are changing, how temporally things are changing. So most of the times you get a newer insight when you are looking at these data sets, which is quite interesting and encouraging to carry forward such type of research.
This data that you're speaking of, how do you get access to such data, and what is the data like? Is it an image?
Well, in India, primarily remote sensing center, National Remote Sensing Center, which is based at Hyderabad.
Okay.
They are the data providers to most of the scientists and researchers like me. Way back when I started this research, we were looking at hard copy photographs.
Oh man.
And we were just trying to interpret things from them. Then gradually image processing came into digital mode.
Just out of curiosity, you were saying hard copies. How would this arrive to you? Right now you have email and stuff like that, and very fast.
Oh my God, in those days, I still remember there were tapes.
Tapes?
Yeah, small tapes.
Man, most of us haven't even seen one of those.
Yes, certainly not. So nowadays, it is hard to convince students and researchers that these tapes were available, and to mount those tapes and extracting data from them, at times it used to take hours.
Of course.
Just to visualize that data. Then subsequently everything came into CD-ROMs. Then we used to get data sets and CDs and all. Nowadays FTP websites, these are available. You need not to rely on these hardware kind of stuff to procure data. Otherwise, one used to wait for that speed post, register post or courier. Courier was not that common in those days, but it was more through Indian Postal Services.
Yes.
You used to get those tapes, CDs. And many a times, it was not very frequent, but sometimes the tape is not working, There is some technical error. Then you have to reorder it and wait for another few weeks to data arrive to your lab. But nowadays, things are pretty fast.
So the technology behind your technology has advanced.
Yeah, certainly. That's it.
So, one specific region of focus in many of your studies has been on understanding the biodiversity in the Himalayas.
Yeah.
Why the Himalayas, and what's so unique about the biodiversity there?
Well, one thing, Himalayas are the largest geographical feature, continuous geographical feature, which are upland, like any other mountains.
Yes.
Then geologically we know these are the youngest mountain systems which are changing, but these are mosaic of multiple like Indo-Malayan plates, multiple plates which have got a unique kind of biodiversity there. And we use a term endemicity, endemic species, which are very local specific in a given geographical location.
So endemic species you can only find it in one particular geographical area.
So what you see there, so you don't get to see them elsewhere.
Anywhere else on Earth.
Yeah. Wow. So and plus the beauty with Himalaya, unlike many of the mountains, is the human population density is very high. specifically in the middle Himalayas or central Himalayas, which is nowhere on the earth in any of the mountain system.
Okay.
It means you have a unique human interaction with these natural landscapes for their day-to-day activities, livelihood options and all. So you get to see a unique type of pressure, which one might call as disturbance
Right.
in ecological terms. So looking at how this pressure on natural forested landscape is affecting. So when we talk about conservation of biodiversity and all, so this component comes very important, And for that we relied on satellite data to identify the locations where we should do the footwork and enumerate or collect the plant species and all. I worked in high altitudes, Nubra Valley, if you have
Yes.
heard of. That is somewhere in higher ridges of Jammu Kashmir, now Ladakh.
Yes.
And so that is again a unique landscape which has very high amount of medicinal plants, which are very unlikely in rest of the mountains because these are true cold deserts.
So during this research, you had to actually visit
Certainly.
the area. It's not just remotely analyzing data then.
No, not exactly.
Okay.
We often in classroom interaction, I say remote sensing without sensing is nonsense. So the meaning is, if you actually want to do remote sensing, you will have to get down onto the ground. Maybe your percentage of data collection decreases, but collecting something we call ground truthing. It is a science, it is a part of the science wherein you actually get down onto the ground and try to correlate what exactly is there on the ground and what your satellite data is telling you. So you wish to combine these two to generate newer type of knowledge.
Yes.
So therein again ground truthing is must.
Every field of science, of course, poses its own challenges. But staying in a place like the Himalayas, what was that like for you?
Oh my God, it was actually very tough. And it is very difficult to walk there in these cold deserts because one is the amount of oxygen is very less,
Right.
and the pressure is altogether different. So it was quite challenging but exciting also.
Must have been beautiful.
It is, when you cross, and incidentally at that time I was in my early stages of career, so I was not having provisions to fly to Leh Ladakh.
How did you get there?
Instead I used to go through road.
Okay.
So going to Chandigarh and then to Kullu, Manali,
Yes.
and then crossing the border of Himachal Pradesh, getting into J&K, and then further climbing the mountains through road. So it was very tedious journey, but it was very exciting. Every hour you will see a totally different type of landscape.
Right.
If people ever get opportunity to visit Trans Himalayas, you see beautiful rocks there of different colors. Flowers of all together different colors, which is very hard to imagine at times.
Wow.
So those landscapes are actually very distinct and beautiful in true sense.
Your most recent study actually focused on the agricultural practices in the Western Himalayas and how it affects the biodiversity in the Nubra Valley, which you just spoke about in Ladakh. In particular, how has the agriculture in that region affected it?
One is changes in the population distribution. Otherwise, my first experience with Nubra was that they had very optimally utilized the land. They tried, bringing in water from drainage with a very man-made canal system, which is very unique in those landscapes, and then cultivating some of the agricultural crops, vegetables and all. But the dependency on these natural resources, and specifically plant resources, is very high, and the demand for those medicinal plants has increased. So, which has put actually a lot of pressure on this. So, we get to understand, and the abundance is decreasing.
Abundance is decreasing.
So, there is huge amount of extraction. Another thing which I would like to mention is, forest and agriculture has a very close linkage in these mountain systems. Many a times, forest provides some of the ecosystem services which were earlier less known, and naturally feeding the agriculture fields. So because forest degradation has taken place, so your land productivity has also decreased. So ultimately you are losing altogether all type of resources.
What are some of the challenges that climate and environmental scientists like you face today in convincing people that we need to act fast? Are there any anecdotes that you could share on how your conversation has been with people in the Himalayas?
Yeah, certainly. Once I was doing field work in Arunachal Pradesh, and it's way back, probably in year 2000.
Okay.
So people were not very happy seeing us and accounting their forest and all. Arunachal Pradesh forests are owned by local people.
Okay.
So I still remember we came back from field work somewhere at 8:30 and all. We were preparing for our dinner and all. So somebody, probably a political interpreter, he tried asking us why are we here. And it actually took us more than 3-4 hours to convince him that we have come here just to understand what the environmental problems are. When we said that we want to recommend for conservation and protection of forest, then only he realized the importance of such type of science.
Oh.
So, to my understanding, local people, they understand the importance of environment, importance of forest, natural resources and all. But the science connect or translating scientific findings, understanding in common language, that is something which is required. So probably we are doing very good science, but we are not actually translating it either in policy documents or something which could be adapted or understood by the local people.
Or even, as you said, just something as simple as actually speaking to the people who are directly involved.
Yes.
Instead of just passing a law or passing a policy.
Certainly. So you need a very close interaction with these communities, which have their own set of knowledge. You may call it traditional knowledge or anything, but the science facts or science findings need to be communicated to them with a very interactive manner, rather than just saying something as a law or any other kind of communication. So we need to bridge such type of gap, and you learn this thing only when you are actually on field.
Yes, of course.
Sitting here in Delhi or in any of the research labs, at times that understanding doesn't come. And most of the time, they love nature and they wish to protect environment, and they will be very happy if science findings can support them.
So sometimes remote sensing needs to have a sensitive aspect as well.
Certainly.
So would you say that the priority of your field is also shifting?
Certainly, as the challenges which are being posed by climate change or our missions towards sustainable development goals. So you need to know things in much better way.
And much faster as well.
And in much faster rate. And at the same time, data set is getting pumped in, with newer equipments, newer tools and all. So again, managing these two things, that will be a real-time challenge, wherein data processing techniques are getting enhanced or need to be researched further so that you can find real-time solutions.
Got it. With climate change increasingly affecting all of us in every part of the world, what would you say are research opportunities in this area?
Great. To me, climate change, though challenge, but it is bringing some kind of opportunities as well. Because climate change is not a local phenomenon, it's a global phenomenon.
Yes.
And that brings in a lot of bilateral, multilateral understandings, agreements and all. And to address things in such a larger scale or at a global scale, you need to have very finely collected data, synthesized in much more sensible way. So it means there is a whole lot of newer kind of research opportunities which are coming.
And I mean, as you said in the beginning of this interview, multidisciplinary approaches are becoming more and more essential.
Yes. So now forest is just not a forest.
Right.
It plays a very important role to mitigate climate change or increase in temperature, which is linked with economics, which is linked with society.
Yes.
So you need to bring these disciplines together.
Right.
So we are with larger challenge, but I see it as an opportunity also, so that people from different disciplines, they in a more meaningful and actual way come together and address the larger questions which can help the global scientists or global policy makers to address things.
So that one set of data can have multiple perspectives. And
certainly, like the data which we started as an ecologist and all, now I see social scientists relying on such type of data set. Legal practitioners or policy makers. So same data set, could be seen from different perspectives.
And once that all comes together, you have a broader view.
Yes, certainly. So those are, I call them as opportunity for better research, wherein players or people from different disciplines come together and address the research.
Apart from being an environmental scientist, you're an avid professor, an avid teacher. And what would your message be to aspiring environmental scientists with respect to what can they expect in this field of study? And why do you think it is an attractive field to choose to pursue?
Well, environmental science, as the name suggests, you are looking at your immediate surrounding and interaction with that. It could be natural, it could be artificial. So basically you are trying to understand this interaction. As a student, one has a huge range of opportunities to learn and to see the science part of this and linking it with the society. That is there. Second is, as things are changing and our environmental changes, our problems are shifting, so you have newer opportunities to carry out research. And research actually demands something which is actionable, which can result into some kind of action on the ground. So one can actually put a dent, in the entire way of thinking. So that opportunity is there. So I find it one of a very interesting sciences. The best part of environmental sciences, it is true multidisciplinary. You need to have some understanding of physics, chemistry, biology, mathematics, social sciences, and then understand in a more systematic way. So that interdisciplinarity of this discipline makes it much more attractive.
Thank you so much, Professor Joshi, for taking the time to talk to us. And it was a discussion on a topic that is literally hot and burning.
Well, indeed, it's my pleasure. I hope I made some sense.
It was remote sensing with sensing.
Yeah.
So absolute sense.
Thank you.
Thank you so much. It is me, Aishwarya Viswamitra, signing off from this episode of Joy of Science. We will be back soon with more such interesting and exciting episodes, so stay tuned. For more such research news and podcasts, please log on to www.researchmatters.in.